Good afternoon, everyone. Welcome back from lunch. My name is Benjamin, and together with Bob, we're going to present to you an overview session about the operations and scalability stuff that you can achieve with InterSystems IRIS. We both work in the Data Platforms Product Management Group and are really looking forward to kind of present you this overview. It is an overview session, which means that we will scratch the surface. We will not get into too much detail about all of the individual pieces. There should be time for questions at the end, and we'll be around. There's also some other true specialists in the room, so we'll definitely want to make some time to address your questions, and there's still the rest of the conference to get into more detail. At the end, we're listing a couple of sessions that go more in depth about particular things. So what will we be talking about today? We'll talk a little bit about an application. We'll talk about how you can deploy that, what happens when that application grows in size, and how you can monitor that application. We'll wrap it up, and then, as promised, we should have time for questions. All right, so let's try to weave this overview session around a true story, a very true story about a killer app that was developed and that we now want to kind of take forward. So an application that was developed in IRIS, it could look a little bit like this. So lots and lots and lots of code, dev done, it's ready to be deployed, it's ready to kind of make big bucks in the market. It doesn't have to be Python. If you like to learn more about developing in Python, at 4:30, our colleague Stefan Wittmann is presenting a session about exactly that. But either way, the application is done and ready to go. So as you can see, if you're into coding, it does really great stuff. Now, how are we going to bring this to market? For this, we've got our two characters. We've got Jack, who is the head of sales, and who's going to make all kinds of promises to our customers. And then Joe is the guy that actually has to deploy this, the guy that has to actually make it happen. So together with Jack and Joe, we're going to walk through what InterSystems IRIS has under the hood for you to deliver capabilities. All right, first step is to get out of the runs on my laptop stage. So we want to run it on a second laptop, and then we want to run it on something proper, something real server-like infrastructure. So we'll let Jack do the talking, and Jack will tell our customers that they can really deploy it anywhere, in any kind, on any type of hardware, even that legacy thing that you have somewhere in the back of the garden shed. So is that true, Bob?
Vaguely, yes. Wow, I'm very loud. So IRIS, as many of you know, IRIS runs on a wide variety of platforms. On the left-hand side, you see the kind of traditional operating systems. These are VMs and VM equivalents, but also physical machines. Our on-prem customers tend to go in this direction. Many customers go down this path. There are a lot of great options that are available for you. We're adding a lot there kind of on a daily basis. We just added support, I don't know if anyone heard this, last week we added support for Red Hat 10. So that is good to go, so you are free to start using that whenever you'd like. On the right-hand side, you'll see a bunch of container runtimes. So IRIS also runs in containers, runs really well. We provide you with those. It runs with any OCI compliant container runtime, so I've only listed 3 of them here. This is probably 2 more than many of you have actually heard of, but you could run on any container runtime anywhere out there in the world and know that it runs safely. We also run on a variety of hardware. So if you want to run an ARM machine, we can support you. If you want to run on an Intel or AMD machine, we can support you there as well. One of the questions that I always get asked is, well, what's the best platform? That doesn't have a great answer because there isn't one. The platform is a combination of what do you need out of it and what can your organization support in a cost-effective and regular basis, right? How do you make this just a normal thing that's part of your IT organization? So if you're doing everything else in containers, deploy IRIS in containers. If you're doing everything else on, I don't know, Ubuntu, deploy everything else deploy it on Ubuntu. If you're asking me what's the fastest, most performant machine that I can get out there today, I can tell you that there are numbers that we have for our benchmarks in the house show that Red Hat or Ubuntu running on top of AMD's latest CPUs are the fastest things that you can buy today. If you'd asked me that 10 years ago, the answer was AIX, but that has not been the case in many years. All right, let's move on to our next thing. So another thing that you're gonna have to do to get out of the lab is not just have hardware to run it on, but think about how do I take my application and deploy it onto that system. We have the InterSystems Package Manager. Has anyone here heard of IPM or ZPM as it's known? Oh, everyone, this is perfect. So I don't have to spend a lot of time on this. This allows you an easy way to package up your application in like a pip package or a Maven package, whatever you would be using for any other programming language, and you can deploy it any way that you want. One of the big things that we've added here recently is the ability to use a container registry as your package registry. So container registries were originally envisioned for just containers, and then people realized, wait, I can put any old stuff in there. So now you can have this server that you can get from any number of vendors that's secure because it's been looked at by many, many, many organizations, not just us. That's easy to deploy and easy to run. So you could run your own package manager, you could use ours, whatever. So that's something that has happened in the last year that I think a lot of people are going to be interested in. Another thing that people ask about a lot is, hey, how can I make configuration easier? Especially when I've got dozens of machines, maybe day one out of the lab, you've only got one server that you care about, but we're going to grow in a little while. It's going to be a very successful killer app. It will kill things. What does it kill?
The market.
The market. It kills the market, yes. Isn't that bad for the market? Anyway, moving on. One of the big questions is, hey, how can I make configuration easier? How can I make it so that I don't, every time I deploy a new IRIS instance, have to go into the system management console and go click, 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 and forget to do something, and then that leads to a problem later, right? So we have the CPF files. I don't know if anyone's used CPF files. There are a lot of people as well. This just allows you to have this simple file that says what the configuration should be. And then we've got this tool called CPF merge that lets you take snippets of that and apply it to an IRIS instance. So you can say, oh, here are all the configuration settings I need for killer, and package them up, then apply them every time it gets run, every time you install it on a running system. And these are idempotent files, which just means make it look like this. No matter whether I need to make a change or not, it will figure that out when you run the CPF merge command. All right, another thing that's really common and popular for getting out of the lab these days, new applications especially, we're seeing a lot of customers adopting Kubernetes. Kubernetes has a learning curve to it. It's part of your containers world, but the people who have gone up that learning curve have gotten a lot out of it. And not just for their IRIS applications, but for many applications all around the business. So we have a Kubernetes operator, and if you want to know more about our Kubernetes operator, the session right after this one in this room is all about Kubernetes and our Kubernetes operator. The Kubernetes operator extends the Kubernetes API to have this simple concept that just says IRIS cluster. And you tell it, what do I want? Do I want it to be mirrored? Do I want it to be sharded? Do I want ECP clients? And if so, how many? And how do I scale them up or scale them down? You just have one YAML file that puts all that together, and you end up with IRIS, the Kubernetes operator, taking care of all of that deployment, setting up all those pods, all the stateful sets, and all the Kubernetes pieces. So it's really nice to use, and if you're thinking about Kubernetes, I really do encourage you to do it. So that is how you get out of the lab.
Great.
So let's find out what our sales exec has volunteered us for now.
All right, thank you, Bob. Okay, so Jack's making some more promises. Who amongst you had a great night's sleep? The bar is not falling asleep during the keynotes, so maybe that's a few more. So that probably means that you're using InterSystems mirroring, and therefore you had the peace of mind to get a good night's sleep because you were confident that in the morning your IRIS instances would still be running. That's what InterSystems mirroring does. It gives you resilience, it gives you confidence. It's really proven technology. It's been out there for quite some time, and we've got many of our customers that are using it in mission-critical environments. How does mirroring work? Every time your application, whether it is directly through global access or through 15 layers of application code, when you set a global or kill a global, we will write a journal record. That's standard practice to be able to roll back your transactions. What mirroring does is it sends that journal record over to another IRIS instance that then applies the exact same change to that system. So it mirrors every change you make on your primary, on your backup systems. There's 3 different modes for that. There's the synchronous mode that you want to have your hot standby, be ready for high availability purposes. So you only kind of get an acknowledgement when it's actually written to the other system. There's an asynchronous mode such that you can have a little more time. You don't need to wait until the other one has written the journal records. That's convenient if you've deployed your backup member, your backup member to a different region, so there's a lot more latency between the primary and the other one. So that's more useful for disaster recovery scenarios. And then there's also the async reporting mode, which is convenient because then that other instance can be used for other purposes, such as serving analytics or some other secondary use of your data. Recent changes in the mirroring space, starting with 25.1, we have simplified the procedure to add a new database to your mirror. Previously, that took a little bit of juggling with files, etc. And now you just add the database on your primary, and the data gets automatically downloaded to your other mirror members. So very convenient. You would wonder why this wasn't happening in the first place, but now it does, so yay. Also new in 25.1 is better throughput. We've changed the journal file format, or the journal record format to be exact. We've made it a little more compact. That does put some limitations on your upgrade procedures in the sense that obviously this new format is not recognized by older instances, but if you follow the regular upgrade procedures, this will all just work. And at very high throughput levels, you'll see that, well, you're able to get to even higher throughput levels. Great technology, but in order to get a good night's sleep, I need to be able to install it first. So how do I do that? Bob already kind of gave it away, but in that IKO, in that cluster topology file, that YAML file that he was describing, it is just a simple flag. You set it to true or false. If you want to update a particular instance using configuration merge, it's this kind of an operation that you apply, and in the system management portal or the command line interface, there's also the procedures that you can work through to make this happen, all nicely documented. It is, as you probably noticed, there's a difference between just setting something to true and then doing all kinds of steps here. That's because in IKO, you define your cluster. You configure your cluster at the cluster level, whereas in everything else, you're always talking to individual applications. So another good reason to look at InterSystems Kubernetes Operator to take care of that orchestration for you. All right, we're out of the lab. We've deployed with confidence in the cloud, in containers, in whichever environment you please. So now let's grow. Let's let our Jack do his work and make some more promises and promise the moon to the world. Promise that we can deploy this in a small scale, we can deploy this at a large scale, at an ultra large scale, at an epic scale. So how does that work? How can you make sure that your application can kind of scale out to support that user workload? So that is something for which caching exists. And if you go to ChatGPT and you ask, how can I cache database information to scale out my application horizontally, ChatGPT will probably give you suggestions like, oh, you could look at Redis, which is a caching technology, or you could look at, for the Oracle database, you could look at times 10, which is a special technology that they put in place. And what all of those do is, so you start off with this application that was nicely integrated with your data, but then when you introduce a separate caching technology, suddenly the fit is kind of different. It doesn't really fit. You got to change your application to kind of match how the caching layer works. That's not fun because we had this killer app, it was dev complete, we really wanted to get rolling. So what we do with InterSystems IRIS, we look at caching as a type of protocol. This is how different IRIS instances talk to one another. So it really is just the lines in this little bit of diagram here. So, and that means that your application is ready to roll immediately. So that's what the Enterprise Cache Protocol is about. Again, proven technology that many of our customers use on a day-to-day basis. Some of the advantages are full transparency. That's what I was just explaining. From the application perspective, there is nothing that changes. The application doesn't need to know whether it's running on the data node or whether it's running on any of these compute nodes. So it has the same recovery guarantees, the same transactional guarantees, very, very practical. It's fully elastic. You just spin up an additional compute container and it's ready to take in user load right away. Of course, it's going to build up its cache a little bit, but it's ready to go right away. And also nice for hybrid scenarios. For example, we have, I live in Belgium. We don't have Thanksgiving, but we do have Black Friday. We've got a big retailer that uses ECP that has a big retail application web store that runs on IRIS, and then right before Black Friday, they just spin up in the cloud a couple of additional instances to take all of that Black Friday workload, and they're fine. And they only pay for that infrastructure during the week before, after Black Friday, and that's all they do. Pure elastic scaling. Mm-hmm. Also easy to organize, as you can see from the diagram. If you've got different applications or different user audiences that access different parts of the application or different parts of your data set, you can just send them a different cache nodes, different compute nodes, and then you'll benefit from some of that cache locality. All right, how do I set it up? Again, very easy with IKO. As Bob already showed you, it's just a matter of expressing how many of these you want, and that's it. That's really everything there is to do about it. If you look at configuration merge or the other options, you'll see that ECP is actually focused at the database level, configured at the database level. So that's kind of low level in the sense that you can get some really nifty, very advanced configurations. But we really recommend, and we're working on simplifying the kind of simple scenario in which you have one application, one namespace, and can easily kind of spin up additional compute nodes for that namespace. So by next Global Summit, by next Ready conference, and we'll have some more to tell you about work that we're doing in this area. All right, so we've seen how we can adapt to growing user load. So more users, more application, more compute. Now, our application is also gathering a lot of data. It's storing a lot of data. So what if that data set grows? That's another kind of axis on the scalability chart. So we're storing a lot of data. So this is a lot of stuff that we're cramming in a single slide here. But let me walk through what these do, because they address the problems, scalability, data scale problems in different ways. So database size, so this is a project that is currently still in QD, but we'll be able to announce it as a platform capability soon, probably with 25 or 26.1, is a new block number format. Currently, technical details, currently our block numbers use 32 bits. So 2 to the power of 32 times the default block size of 8K gives you this magical limit, this horrible number of 32 terabytes as the maximum database size for an IRIS database. If you use larger block sizes, that can grow a little bigger. But that's sort of the current limits. We'll kind of push that out further by using a new block number format. And that's all lots of technical detail. And as you can imagine, this takes a lot of QD work to make it sure it's as robust as you expect it to be from us. But the big thing, or the nice thing, the way how it was implemented is that it's going to be a natural transition. So you don't have to migrate your data to this new format. We're just making use of some space that we had carved out for future use. And that means that if you have your 31.9 terabyte worth of data, you don't have to stare at a progress bar that kind of migrates the data. No, it will just poof, be migrated into this new format transparently. 32 terabytes sounds great. Well, you can grow into the petabytes now, but a 1 petabyte iris.dat file, that's not very practical to work with. So this is what table partitioning, this is what multi-volume databases help you with. Multi-volume databases is something that we've had in the platform now for a little over a year. It means that after you reach a particular threshold that you can specify, for example, 2 gigabyte, 4 gigabyte, we will automatically roll over into a new database file, a new volume file. So it is still logically the same iris.dat file, but physically it's stored in different volumes that you can spread across different database or different file systems, and therefore you can bypass some of the file system limits or operating system limits on maximum file size, and it just gets a little more practical to work with. So that's what multi-volume databases is. It's a great default thing to switch on. There's really not much that you have to do or know about it. It's really a very simple thing. As we talk about large databases, there's a couple of other smaller things worth mentioning. We've increased the speed at which you can expand databases and which files by using some low-level, let's say, metadata operations, and also improved the performance of database truncation, database compaction, especially for those that have large strings, big strings. That has now gotten a lot faster. Table partitioning kind of looks at database size in a different way. So it really is looking at not just trying to stash more data in a single database, but rather to organize your data across multiple databases, because not all data is equal. If you're in a financial services company and you need to, we're back in our retail scenario, the transactions from this week, they are important. You want those to be fast, you want to be able to look at those quickly and efficiently, but the transactions from 3 years ago, not so much. But by default, they're gonna be in the same table, they're gonna be in the same global. So with table partitioning, we allow you to spread that data based on a logical criterion, say transaction date, and spread that across multiple database files. So this is a new capability that's currently in early access. If you're interested, go to the InterSystems.com/early access program. There's a QR code at the end of the presentation, and you can join the early access program and get access to the latest kits. And play around with this and see how it fits. There's also a nice demo that Dmitry Bochkov, who is the development manager for that part of the platform, is going to give tomorrow at 2 in the Tech Exchange. So how do we configure all of this? Extended database size is going to be a system-wide flag and really nothing else that you need to worry about. Multi-volume databases, you just specify at a database level at what threshold you want to start your next volume, and then the folder where that next volume should be created. That's it. Table partitioning, of course, is a little more, requires a little more, because you need to specify how it should partition your data. I want to partition it on transaction dates or log timestamp in this case, and then there's some more. If you join the early access program, we'll send you a tutorial that kind of walks you through everything there is to know. All right, so that was the scaling part. So now we've got everything running in a very stable way. We're ready to scale for user load. We're ready to get those petabytes worth of data. And maybe by now we're at like 20 some servers. So how can we take a look at those and make sure that they're running nicely and still in order?
Right. I mean, once you're running at this scale, you want to make sure you can sleep at night and that all of your systems are running the way that they're supposed to.
Sure thing.
But before we get there, Benjamin, I just noticed something. If we go back to this slide here, come on, one more. Who knows what that logo in the middle actually stands for? Yeah, I remember those things. Are you suggesting people use floppy disk sized 400K partitions?
That was to illustrate the fact that there's limitations to disks.
There are limitations to those disks, yes. All right, sorry. I distracted us from our actual presentation. Right, so here now we're talking about the operations side again. Right? How do you monitor your system? How do you know what's going on? How do you know that everything's running at peak efficiency? So IRIS has a gazillion built-in tools. I'm not going to spend a lot of time showing you all of these. These are all in the documentation. We've got the system management portal and all of the tools that are in the system management portal. We have command line tools. We have ones that are performance history specific. We have ones that are kind of software profiling specific. I'll switch over to page 2 here of these. We have even more. The one I want to talk about here that's new is we've added the ECP tool, or we've extended the ECP tool so that it's easier if you're using ECP in a lot of servers to really know what's going on the ECP side of the house. If you want to be looking at current problems, if you want to investigate something that might be happening, it doesn't have to be a problem, but it just could be what's the current need of your system. You can investigate that. All of this is available in our documentation. I put the whole URL on here knowing full well that long URL you're not going to type in, but you can type Google InterSystems IRIS monitoring overview and it'll bring you to all of this. All right. What's new and interesting in the operations and observability world is the thing called OpenTelemetry. Do you all know what OpenTelemetry is? Few of you? Okay. So OpenTelemetry is about standardizing the collection and distribution of what's called telemetry data. So this is information like logs and metrics. So metrics being like CPU utilization and that kind of stuff. And something they call traces, and I'll talk about that in a second because it's a little different from an IRIS trace. But it collects all of this information in an industry standard way and lets you ship it off to an observability platform, which allows you to do alerting and visualization of that data. So if any of you have used Grafana or Loki, or you've used Datadog, or any of a number of other tools, I mean, there's hundreds of observability platforms out there. Those are all observability platforms that take this data, this time series data, and let you visualize it and work with it and set up alarms and all of that kind of good stuff for it. So what's new with IRIS in 2025.1 is that we now have an included built-in OpenTelemetry exporter. So if you are using OpenTelemetry in your data center, which really, again, new setups, kind of everyone is, and you're running on Linux. I'm sorry, this is a Linux-only feature, so all these running Macs in production, too bad. Then you can very easily just enable this and send all of your observability data to the server. I said I was going to come back to traces. And what are traces? So here, traces are these things that are looking at what happens, what are all the stages of work to resolve one request or one work order. So it starts at this time when a web request hits this server, and then you notice it gets routed to this server and another microservice and another microservice, and oh, gee, this one took really long. Why is this section here taking so long? It lets you investigate those kinds of performance issues. But it's that kind of visualization that you can do over and over again. So we've now also instrumented IRIS with traces. So you've a new monitor tracing API that you can extend. And in 2025.2, by default, your CSP REST and your other inbound web requests will automatically be traced if you have tracing turned on. All right.
All right.
That's really all we had prepared.
Yeah, just to kind of summarize again. On the deployment side, to get out of the lab, we're allowing you to use any style of deployment that you want. We're supporting all of those. So if you want to stick with on-prem installations on your own hardware, you can do that. If you want to use a virtualization layer like containers, you can do that. And you can really do yourself a favor by adopting the InterSystems Kubernetes operator. Using mirroring, you can make sure that that whole environment is rock solid and secure. Then as your user audience grows, as your database grows, we're there to help you support those use cases with ECPE. We have the multi-volume database that's already in the product and table partitioning that is coming soon to manage large data sets efficiently and economically. Maybe a small nuance that I forgot to mention when we were looking at that earlier on is that in the multi-volume case, it's opaquely pushing the next blocks onto this new volume. So you can't really control which data goes where because it just blocks. That's what table partitioning does. Table partitioning gives you the ability to control at a logical level what data goes where. So that's the difference between those two. So that's for the scalability piece. And then on the monitoring side, to get from just sheer luck to a well-controlled, well-governed environment, we've got these open telemetry metrics, logs, and traces that really help you manage your instance in an industry standard way. Also worth noting is that for all of the things that we talked about, there's practically nothing that you need to change to your application. Only for the things that naturally apply to your application, like table partitioning. What is the field that you want to partition on? Or traces? What are the kind of pieces of your workflow that you want to be a separate span in your trace? Only at those moments will you have to kind of opt into those capabilities in your application. For everything else, the code that we showed you at the beginning will run as if in the environment, however you adopt these capabilities. So, cheesiness alert. So with InterSystems IRIS, we had to do this for marketing. You're really ready for scale and operations at any scale. So Jack and Joe having a good time, and I hope you had a good time as well. Here are some suggestions of other sessions that you might be interested in that talk, for example, about IKO, about the package manager, and some of the other things. I mentioned the table partitioning demo, open telemetry tomorrow as well. So please join those.
Don't forget the ice cream social. That's the most important one on this list.
Early access programs, you can register for them here. If you're not quick enough to take a picture, you'll see it at the end of every session. Otherwise, the presenters haven't followed the instructions. Please also check the app, which also has the link to the EAP area. And leave your feedback for this session, but also for all other sessions, because it's very valuable for us to know what kind of content you like, what kind of delivery mechanisms you like, and then we can make Ready 2026 even better than this week. And with that, thanks a lot for your time. And if there's any questions, please give a shout. We do have, maybe we can just run around with this microphone.
We have quite a number of customers who are using containerized IRIS for mission critical. Sorry, the question was, hey, what's up with containerized IRIS? Is it appropriate for mission critical applications? And the short answer is almost always. It's always about what is your application and what are the very detailed specifics of your application need. But there's really nothing specific about IRIS in a container. It's still IRIS at the end of the day. The data is stored in network attached storage, just like you'd be doing in a VM. So, from that perspective, there's nothing really to worry about. When you containerize IRIS, you will want to do a few things. You'll want to make sure that your application and your container is set up correctly with your application in it, and that you've thought through all of your upgrade processes, and that you have you've put in hooks for various container lifecycle things like the readiness probe and the startup probe and all of those sorts of things, so that you can start up cleanly and shut down cleanly. The biggest area where people run into trouble is if they say, ooh, I've got some interoperability production that I want up and running, and they forgot to change their readiness probe to make sure that their interoperability production is in fact running. Any other questions?
So you were mentioning about that journal files for the mirroring are changing. And so if you have a bunch of mirrors, like say 5 or 6 different mirrors, and they're different types, like primary and a backup, and then some DRs, and then some read-only ones. So if you upgrade the read-only ones first, is that how you do that? Because
Yes,
would they be able to read the backwards compatible?
Yes, indeed. That's exactly what I was going to say. Almost the same words I was going to use. Just to repeat the question, what is the recommendation for your upgrade path given that change to the journal record format? That is to go backwards. Start with the kind of furthest out ones, the reporting nodes, the asynchronous nodes, then your synchronous backup member, and only at that point you switch over and upgrade the other one. So that's because an IRIS 25.1 instance can still read the journal records from a 24.1 or whatever, but the inverse is not true.
The features you described, the observability stuff to integrate with OpenTelemetry, is that, you mentioned IRIS 25, would that come out at the same time for IRIS for Health, or is IRIS
Yes.
for Health?
It's only available on Linux, but it's available for IRIS, IRIS for Health, and Health Connect.
About the conversion, you told about the use of Kubernetes, okay? But in a full key installation, okay, on a Red Hat, for example, to do this upgrade of the instance about the database, you told it that that's a limit of 32 terabytes, and there is a conversion. It's a possibility to cause a problem of the database in the database, like in other cases when you change the operational system, you have to do a save engine to there is any type of this?
There's not that kind of a transfer. So how it's going to work is we're going to introduce support for the new, we call it extended database format in 26.1. What that means, but by default it will be off. So by default you will still kind of run out of space if you go to 32 terabytes in an 8K block database. But you can switch the system-wide flag on, and if the flag is on and you're at 31.8 terabytes, we've done some math to kind of work it out in a clean way, that we're not doing it too early. Then we just change something in the header block of your database to tell it that it's now using the 40-bit block numbers rather than the 32, and from then everything else will start working. The reason why that's off by default is for exactly these upgrade and mixed version deployments. Because if you say you would be failing over to an instance that does not yet support that database format, you're in trouble. Or if you have an ECP app server that doesn't support it, you would be in trouble. So we're going to have that off by default in 26.1, and then probably 2 years later, to kind of accommodate most people's upgrade practices, we'll make that on by default, and we'll make sure that it's clear from the documentation what is happening at what point in time.
Thank you.
One more.
My question is about when you reach the file system limit. I know over the years we've had to do like G-block copies and stuff like that. The multi-database, when it reaches the physical file limit, that's completely transparent. There's no downtime, no nothing, and it's for any.
So-
Oh, go ahead.
Yeah, so multi-volume databases is transparent, but it's not, if you're already at 9 gigabytes and you configure the threshold to be at 4 gigabytes, then it will immediately start a new volume, but it won't go move the data from that already existed into a new thing. So there's, again, no immediate blocking change process, migration process happening the moment you switch it on. If you do want to cut it up into 4 gigabyte pieces, you can use a G-block copy or data move to get the data into a new database that from the get-go uses multi-volume database.
And this is like application independent. This would apply to a
Your
system
application
index in
really can't notice.
data.
Okay. All right. Thank you.
You're welcome.
My question is about the mirror process. When you have a mirrored environment, I noticed on your earlier screen you had an arbiter. Is an arbiter, is that a requirement? And then and if it is or if it's not, what's the arbiter's play in a DR scenario, like where it's asynchronous?
I think, well, we've got Mark smiling in the back, who's got the absolute best. Yeah, why don't you give the answer? I think.
Microphone, Mark.
Thank you. So the arbiter itself isn't in the critical path of operation. It's there purely as a witness. Should the mirror members not be able to communicate with each other, they will communicate then via the arbiter to determine who's alive, who's not. In a DR scenario, the arbiter is, I'll say, less important. Because in a disaster, you're going to make the manual decision to promote it. And that's deliberately done on our part because we do want the man in the middle to promote because there is the assumption there may be data loss because it is asynchronous. So we want you to make that decision saying, yep, I'm okay with it, rather than some automatic process coming along, promoting it, and now you have data loss, but it was a planned event kind of thing, and you didn't want that to happen.
Thank you.
All right, thank you. I
Thanks
think
a lot,
with
Mark.
that, we're out of time.
Yes.
Oh, I have another
But if-
question.
What,
So on the multi-volume, is there a limit on the number of volumes per database set?
There
In the past,
is.
it was 8.
What?
In the past, it used to be
Yeah,
8.
but that's so there has been a feature called multi-volume database ages ago.
Yep.
You're giving away your age, Mark. But but that is we've restored the ID and maybe some of the underlying infrastructure for it. But the kind of managerial pieces have been changed. I don't know what the current limit is, but it's really in a couple hundred. So
Right,
you-
so it's
you're
not
should be
8.
fine.
yeah.
Okay, great, thanks.
All right,
thanks
thank
again.
you, everyone.